You didn't have to wait the 20 minutes for these samples to run, but I had to wait 20 minutes for these samples to run. So now all 4 of these samples have been processed, and when the machine gets finished with them, it goes back to the batch table. It gets rid of the chromatogram that you see on the screen just to kind of signify that it's done with the chromatograms, and that's why it goes back to the batch table, to let you know it is finished with the batch. Now, once again, I can always go through and toggle between the data acquisition tab and the batch table, but if I want to take a look at the chromatograms, I can just kind of scroll back and see what showed up, if anything showed up at all. So remember that tab that's down here at the bottom. Okay, now we need to take a look at what the data looks like, right? We've let the machine run the samples. The samples have been processing through the column into the UV vis detector. The detector has now seen it. So it's registered it on the chromatogram, and I need to go through and take a look at what these things look like. Okay, so how do I do that? Where do I go for that? Well, if I minimize this screen down and I pull up this LCSolution main tab once again, this is where we chose the instrument 1. If I go into the post run tab, or the icon, I'm going to look at the data after I have ran it, right? So I'm going to hit post run. It's very important that you close out everything that you have done in the real-time analysis, because if there are samples that are processing, or if the method is still open, then it will cause a problem with the software where it will want to shut that information down and delete it permanently. So you don't want that to happen. So we're done with the real-time, right? So I can go File and I can just go Exit. I want to get out of real-time. I don't want to be running things in real time anymore. There's nothing else to run. So that's always kind of the safe way to go in and take a look at the data to make sure that it doesn't delete anything that you want deleted. Okay, so this is the post-run analysis screen. It looks very similar to the real-time analysis screen. There's just no chromatogram on it, right? So up here at the top, you're going to see post-run analysis. You want to make sure that this says post-run because real-time looks very similar and browser looks very similar. So just make sure it says post-run. And I want to open up one of these files. So I'm going to go to File and I'm going to go to Open. And I'm going to choose the folder that this file is located in. So let's look at our cholesterol high that we ran. So I'll click it and I'll click Open. And now it pulls up the chromatogram that was ran. I didn't get to see the chromatogram because I wasn't over here at the instrument when it ran it. I was doing some other things. So when I come back, I want to take a look at what does this thing look like? Did it behave the way that it was supposed to have? Well, this is the chromatogram that showed up on the instrument when it ran the sample. Again, it shows mainly one large peak, and that large peak is there. That is symbolic of one component. The issue that I've got, though, is this kind of wobbliness that happens here at the end. We call this peak tailing. So the tail end of the curve is a little wobbly. That means I'm not really picking the best mobile phase, and I'm not really picking the best stationary phase for this setup. So that's something in method development world that I would want to go back and maybe kind of clean up a little bit to make sure that these peaks don't take this wobbly looking tail. This can also happen in the beginning. We call that peak fronting. So a front could happen where it slowly goes up, 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 and then it comes straight down. This is the opposite. Peak tailing, it goes straight up, which is what it should do, and it should go straight down, but it doesn't. Instead, it takes its time and it wobbles its way through the column and through the detector to be seen. What are these numbers up here at the top, right? There's a huge big long number that's here, and then there's a huge big long number that's there. This number is what we call retention time. This is the time that it took for, in this case, cholesterol to go through our instrument and come out the other end. So 0.87 is kind of where it's at right now. That means it took 0.87 minutes for this machine to kick cholesterol to the curb. Now, there's a 1.499 listed as well. This 1.499 is another peak that the machine has registered. So this could be due to maybe some cross-contamination, maybe some contamination or trash that's in my mobile phase that I decided to use. Maybe I didn't use the purest of the pure, and any of these contaminants will come through on me. Not only that, but the pipettes that I use to make the samples with, that could also cause an issue because maybe they weren't completely clean. It doesn't look like there's a peak here at all, right? I mean, if I just used my own judgment to look at this chromatogram, and if I look down here at the bottom without the numbers, it's the same thing. This one just has the times, this one does not. If I look down here at the bottom and I see this chromatogram, this looks flatlined to me. I don't see a peak, but if I click and hold in and drag into this area, then I will actually see a hump that leaves from the baseline and eventually returns back down to the baseline. So there is something that is there. I just don't know what it is, and I'm not really concerned with what it is, because as long as I just focus on my chromatogram for cholesterol, that's all that the lab wants me to do. So whatever component you're looking for, that's what you need to pay attention to. Who cares if more of these times show up? Only your big major one. As long as that one has a time, we're good to go. We'll take it, we'll go, and we'll process it. Okay, so something that I want to say. This machine's expensive, but the machine is not good enough to know that that peak is cholesterol, right? You know it's cholesterol because you made the sample. You ran the sample. You saw one big fat peak that shows up on the screen, and that peak is at 0.87 minutes. You know that from experience, from your background. The machine doesn't. The machine does not know what that peak is supposed to represent. The machine doesn't know that that is cholesterol. That's why it has not labeled it as cholesterol. The only thing that it's done is put a time on it and said whatever this component was, I don't know what it was, but whatever it was came off at 0.87 minutes. It does not have the capability to tell me what that peak is supposed to represent. Bottom line, that's something that I have to do as an instrumentation operator and as a laboratory technician. I have to go through and I have to tell the instrument what that peak is supposed to represent. But for us, we'll keep it simple. So as long as you get this chromatogram with the retention time on it, that's all that we need. We don't necessarily need it to print off on a report for us. So if you go back and you remember in the batch table, I assigned it a report. I said I want you to print off on a report template, and this is what I want you to use as the template. Well, the nice thing about doing that in the beginning is that this report's already ready for me. So how do I look at the report and the numbers? Well, if I go over here to the side and I go into some of these buttons that I see, LC data analysis, calibration, batch processing, data comparison, report format, and library editor. Okay, well, what button do I really need to push on here to take a look at the report that was made? Well, if I go into LC data analysis, this gives me some other icons. I can analyze it. I can data report it. I can apply this to the method that was ran, or I can do something that's called a wizard. The only button that you need to be focused with here is called data report, right? I want to look at the report, so therefore I click data report. Now you're probably saying, well, how is that different than the other one that I just saw on the previous screen, right? If I go back up to top, this takes me to the main menu over here to the left. This says report format. This is me going in and making a template from scratch. That's not what I want to do. The template's already been made for me. I just need to print off the report. That's the thing with report format. It makes the templates. So I need to go into LC Data Analysis. I look and click on Data Report, and when I do that, this screen will show up. It tells me a little bit about the information that I've keyed in up here at the top. It tells me the vial numbers. It tells me the time and the date that I injected it. Here it shows me the chromatogram that I saw on the computer screen. And then down here below is some of the information that I need to use to start the data processing as far as calculating concentrations of stuff. Notice that this table is pretty straightforward. There's a column that says peak number. It says 1 and 2. Well, peak number 1 has a retention time of 0.873. If I look up here at the chromatogram, there is 0.873. So that's the information that goes with this big peak. Peak number 2 has a retention time of 1.499. If I go up here to the chromatogram, that was that small little tiny peak that I couldn't hardly see, right? And it's listed 1.499. So this peak number 1 at 0.873 minutes gives me an area. And that area right now, as it's listed, is 3,371,244. What does that represent? Well, what's happened is that you see that small arrow that's here to the left and the small arrow that's there to the right. That is the software going in and saying, all right, bigger peak, more stuff. So therefore, I need to go in and calculate how big this peak is. And it does that by calculating the area. It calculates the area under this peak, and it reports it as a number. And that number is provided to me at this table down here at the very bottom. It also goes by height. So it's reported a height number for me. And it also calculated an area percentage. That means that this sample is not 100% pure. It's 99.49% pure because due to the other areas of the other peaks, I saw some contamination. Not that much. That area was extremely tiny compared to 3 million, but it's still there. And this machine lets me know that 0.5% of my sample was impure. Okay, so what do we do with this information? That's going to be the purpose of the next video. The next video will walk you through on how to process the sample data that has came from this equipment. But what you need to remember is that this report gives you a number that you will need, and that number is the area number. So this is the number that we're going to be referring to in the upcoming video. It's the area. So I will have off already the area for the high, the area for the low, and the area for the mid or middle. Those were the 3 standards that I made and ran on the piece of equipment. Alright? If I wanted to print this off, because maybe I want a sheet of paper that tells me what to do, only thing I have to do from this point is hit print over to the left, and this will print off on a physical sheet of paper that I can then put into my lab book and reference to from that point on.